This is video 3 in our chemical equations and reactions series. We're going to talk about some special classifications of reactions such as redox, acid base, and precipitation. So first we're going to talk about redox reactions. Synthesis, decomp, single replacement, and combustion reactions can be redox reactions as well. Redox is short for oxidation-reduction reaction. And this is a set of two reactions where electrons are going to be transferred from one substance to another so that the oxidation numbers of the elements are going to change. If the oxidation number of the element increases, that means that the element is transferring electrons to something else, so it's losing electrons, and that is oxidation. Reduction is the opposite. This substance is going to gain electrons from something else, and it is going to have its oxidation number decrease. So in order to identify something as redox, you have to assign oxidation numbers to everything in the reaction and see if there is a change. There are a lot of rules that govern what the oxidation numbers are. We've already learned some of them, we just haven't looked at it straight on. So let's take this synthesis example for starters. We know that elements are neutral, so their oxidation numbers are always zeros. We know that some elements, when they oxidize, when they ionize, they always have a certain charge. So sodium and oxygen over here on the reactant side by themselves, their oxidation numbers are both zero. But in this sodium oxide compound, we know that the sodium, being group 1, is a +1 oxidation number, and the oxygen is a -2. So if we look from reactants to products, the sodium's oxidation number went from 0 to +1. The oxidation number increased. Sodium was oxidized. Oxygen's oxidation number went from 0 to a -2. It decreased. And so oxygen is being reduced. One of the reasons why they call this process oxidation is that oxygen is really good about oxidizing other substances. So in other words, oxygen likes to gain electrons from other things. And so the substance it's gaining electrons from will be oxidized and it will be reduced in the redox reaction. Now, oxygen doesn't always have to be your oxidizing agent. It's not always reduced. So if I turn the previous reaction around into a decomp reaction, in this example, the sodium's oxidation number is going to decrease from a +1 here to a 0 here. So it is being reduced. And the oxygen is going to go from a -2 to a 0. So it is oxidized. Let's look at something a little more complicated. Single replacement reactions. So we have to assign oxidation numbers for everything to see what changes and if anything changes. And not all substances, not all species in the reaction have to have an oxidation state change. Some of them won't. So if I go and I assign oxidation numbers, in this copper 2 chloride, the copper is a +2 because that's its charge as an ion. And the chlorine is a -1. The elemental aluminum is a 0. On the product side, the chlorine is going to stay a -1. But now the aluminum has oxidized to a +3. Remember, I can figure that out by reversing my crisscross. And then this copper has gone to a 0 because it's in an elemental state. It's by itself. So if I look at it, the copper is going from a +2 to a 0. It is being reduced. The aluminum went from a 0 to a +3. It is oxidized. And the chlorine isn't changing, so it's not actually taking part in the redox part of the reaction. And finally, if we look at this combustion reaction, we have methane reacting with oxygen to produce carbon dioxide and water. So to assign oxidation numbers here, first, I know that the oxygen by itself on the reactant side is a 0, and here it's a -2. So already I can see that oxygen's oxidation number is going to decrease. So now I need to figure out oxidation numbers over here. So there's two rules that apply here. Number one, hydrogen, if it is the first element in the compound, like here, is a positive 1. If it is the second element, it's a negative 1. So here, hydrogen is a negative 1. The second rule I need to be aware of is that compounds have to add up to 0. They are neutral. So if I have hydrogen as a negative 1, and there's 4 of them, I have a negative 4 charge from the hydrogen. To balance that, the carbon is acting like a plus 4. On my product side, if the oxygen is a negative 2, and there's 2 of them, then this is a negative 4 charge. The carbon is staying a plus 4 to balance. However, here, the oxygen is a negative 2. The hydrogen is going to a plus 1 state here. So I have my oxygen going from a 0 to a negative 2, and I have my hydrogen going from a negative 1 to a positive 1. So the oxidation number of the hydrogen is going to increase, and it's being oxidized. And the oxygen is being reduced, it's decreasing. Double replacement reactions will almost never be redox reactions, but they can be subdivided into acid-base or precipitation reactions. An acid-base reaction is fairly easy to recognize. Its name tells you what's going on. An acid is going to react with a base, and it produces a salt, which is some ionic compound, and water as its products. And this is also known as a neutralization reaction. So in this equation, nitric acid is going to react with sodium hydroxide, so we know this is an acid, and that's a base, and it's going to produce sodium nitrate, which is what you get when the sodium and the nitrate ion combine in the double displacement. And then water is the other product, because the hydrogen and the hydroxide are going to combine. Other times you can have double replacement reactions become precipitation reactions. A precipitate is an insoluble solid that will form from a reaction between two solutions. So you'll have both of your reactants are aqueous, but one of your products is a solid. So in this example, silver nitrate and sodium chloride will combine to form sodium nitrate and silver chloride. And we will get into the rules to figure out whether something will precipitate or not when we talk about the solutions unit. But suffice it to say that silver-containing compounds don't like to be soluble in water a lot. So this is why that ends up being my precipitate. All right. Our last video in this series is going to be over balancing chemical equations.